This is Nathan Cruz with Carlson Software, and in this video I'm going to demonstrate some of the surface volume tools that we have, and also point cloud volume tools, and some advanced use cases. So I'm going to start by opening a P3D scene file for the Michigan quarry, for a quarry site, and I'm going to go ahead and load the point cloud, which I've already selected, but this is part of the demo data set that you can download from carlsonsw.com on the downloads page, and it's under Aerial Drone Survey, Michigan Quarry Colors. Has about 15 million points, and in this case I'm not going to apply a projection. I'm already set in the projection for Michigan South, and it is a metric data set. So go ahead and load the point cloud. Now, once the point cloud is loaded, we can zoom on in here and we can find our area of interest. And in this case, I'm going to compute the pile volumes for this pile and for the pile to the north here. So this particular area is pretty clean. It doesn't look like I need to do a lot of cleaning on the pile to the north, but I do notice that there is a conveyor belt that's above the pile here to the south. And so what I'm going to do is go in and we have a number of tools that can clean this up, but essentially I'm going to use our point Isolator, which is our newest and I think our much easiest to use tool. Very powerful, very simple to use. So I'm just going to click on the point Isolator command, and what I'm going to do is draw a red rubber band, and I'm going to enclose all the points along in here that I want to get rid of. And it's okay if you pick some points that you don't want to get rid of, because we have a way to remove those from the selection set. So once I've enclosed the area of this conveyor above the pile, I'm going to keep enclosed in selection. And once it finds and identifies them, it's going to highlight them. So you can see in the top of the command window we have a coloration method. So you can pick a number of choices, but highlighted seems to work very well. So we just brighten the original colors, and you can see very easily which points are actually selected. So you can see that we've got the points that are floating above the pile here and over here, but we also have some additional points that we didn't really want to get, that we don't want to get rid of. And for the pile volumes, you probably don't really care about this, and you could delete it, but it's just as easy to come out and to pick another polygon here around this area and basically say remove enclosed from the selection set. So we build up a big selection set, and then we can use this remove enclosed from selection as many times as we need to. And once we're finished, I'm going to hit delete selected points, and you can see that we've cleaned up the area here. There might be another little point straggler in there, and you can go in and do some fine-tuning if you want. So now we have the conveyor belt cleaned out from here, and again we have another coloration method that's reasonably useful for identifying the toe of slope on here. And so if I change the contour step to maybe every 2 foot, I'll see if it changes very much from this toe, and it doesn't really, so that's really the outline of the pile that I want to get here. So this visualization tool is nice because we can show you contours directly in the point cloud. You don't have to generate a surface first, which takes a lot of time, especially when you have tens of millions of points in the scene. So what I'm going to do now is simply start the draw polyline command. It's a white polyline. We have lots of different options here, but I can tell it to give me the elevation text as I draw along in here. And so what I'm going to do is just start drawing. Now I toggle on this elevation, and you can see that it's tracking as I'm clicking, it's telling me what the elevation is in this area, and I know I'm looking for about 831 around the bottom of this very flat area. And you could be as precise or coarse as you need. And so I can zoom in here a little bit, and you can see that this is 832, 833, so it's slightly going uphill, slightly going downhill here, but very gradual and very similar elevation. And instead of jumping directly into creating the volume report for this, we loaded this point cloud 15 million points. And I know from doing this, processing this data before, there's close to 800,000 points inside of this polygon right now, which is really a lot more than you need. So we have tools. So you go ahead and calculate it just fine with this, but you can also do a filter command. And what I'm going to do is just start the filter command. This is the hammer and saw icon. I'm going to hold the control key down, and I'm going to hold the right mouse button down, and I'm going to drag to the left, similar to CAD, where we're dragging a crossing, and I'm going to pick up that polyline. When I do this in the filter command, what's going to happen is any one of these filters, the resample, the background, the outlier, the shadow points, will the algorithms will be constrained to any point that is inside this polygon. So this is a really good way to be more aggressive if you're trying to do bare earthing and get rid of cars and buildings and so forth, but you want to leave hills and valleys and your topology more alone. And so we have this ability to essentially really identify the areas of interest. And what I'm going to do is I'm just going to resample every half a foot, and I'm going to hit the apply resample grid filter. And what it's doing is it's going in and removing every point that's more than a half a foot, or less than a half a foot apart. And so you can see we've removed 730, essentially, thousand points. And we're still left with many, many points. And I'm going to go ahead and now I could also do an outlier filter in here if I wanted to, because I know there's some spikes and a little bit of noise on this surface. That's generally not going to really affect your volume report very much, but you can always hit the remove outlier point filter and see what the result is that you get back. And in that case, it did remove, so these are the holes that were created from the conveyor belt because we were shooting the camera angle straight down. So that's not really a problem. That'll be interpolated at such a small area. But it looks like it's cleaned up the noise pretty nicely. So I'm just going to go ahead and hit finish command. And I'm going to put this back into color mode, so we can sort of examine a little bit better. You can see it did a pretty good job of getting rid of points that are floating up above. There's still, I think, one or two little points up here. And these points here are actually the material falling off the conveyor belt captured by the camera. But what I'm going to do is use the point isolator to delete them. Alright, so it's selected those points, and again, it looks like it's also selected some points out here, but easily removed, so I'll just very quickly draw out here and remove those from the selection. Then I'm going to hit delete. Now those points are gone. Much better. And now I'm going to use the volume tool. So calculate volumes command works with point clouds and polygons. It works with surfaces and polygons, and it will also compute volumes between two surfaces. And so what I'm going to do is start the command. I'm going to click on the point cloud, and it's telling me to select the polygon next. Or I can draw a polyline, and in this case I already have it selected, so I'm just going to hold the right mouse button down and select it. As soon as it detects the selection, it automatically starts the calculation, and it's going to calculate the cut and fill volume, cut and fill area, and then we'll also produce the actual surface that was created internally for the volume calculation. And we produce the surface so that you can view it and really verify that it's good. You can also take the surface model and you can right-click and save it and export it out as a land XML file or a Carlson TIN file, TopCon, or Trimble surface files as well directly. And so we get the report. If I click on our status bar here, you notice we've got the daylight, we've got the area, we've got the cubic. In this case, I had it set for imperial settings, so you're going to get your answer in whatever units that you have set up in the Tools, Settings, Units of Measure tab. But I can take this and right-click and basically copy it, and then I could paste it into Excel or into a Word document or into a PDF editor for a report. So if I turn off the point cloud, you can actually see the surface model that was created. And again, you know, this is a good way just to visualize and verify that you don't have any outliers or any significant errors going on in there. Another tool that we have is if you want to include this picture, this image, you know, for your report, you can come and set up the view the way you want it. You know, maybe we might want to view it from this angle. So whatever you have in your view inside of this rectangle, we're going to use a command under File, which is Save to Image File, and I'm just going to call it Pile 1, and press Enter. And what that does is that creates a JPEG image for you. That can be added to your report so that you have your full text of the computed results, and you also have a picture of the actual pile in question, and you have the individual surface model that you can save out to archive to go along with those numbers in that report. So if you're monitoring or doing things week to week, you'll be able to look up that archived information very, very quickly. So the next thing I'm going to do is go to another pile in here, and we get this request where we have basically a pile that's up against a hill, or you end up with a pile that is up against. Let's see, I'm going to get rid of this volume surface, I think, and the old Polyline. And let's see, zoom back into my area of interest, which is this one right here. So in this case, I'm going to turn off the pixel optimizer here so we can see every point. So the problem with this kind of scenario is essentially you have the pile encroaching on this wall or this hill, but you still want to include that portion in your volume report. So whether or not you have a vertical retaining wall and a corner going on here, this same technique will still work just fine. So one thing I'm going to do is go to this corner of the pile, and I'm just going to look at my tooltip and see it's 831.65 roughly. 831.65, and then over here we've got about 832.3. So what I'm going to do is just kind of split the difference, and I'm going to remember that number because I'm going to use a special planar snap that we have to snap to that elevation. So that's going to be 832, I think. Yes. And so what I'm going to do is start to draw a polyline, and I'm going to just pick out here around the pile, like we normally would around the toe. Now when I get up into this area, this is where it starts to encroach. But what we want to do is we want to measure the dirt under here and capture the pile. So I'll try to rotate around here a little bit so you can see what is going to happen, and that is I'm going to set the planar snap to snap at a fixed elevation underneath this area. And so I'm going to turn on the planar elevation snap, which is in the snap toolbar, and it looks like the little diamond eye. I'm going to turn on the planar elevation snap, and I'm going to type in 832. Press enter. I'm also going to no, I'm not going to dock that just yet. Actually, maybe I will. I'll just go ahead and put it over here. Now what's going to happen is, even with me looking down, every time I click the mouse, it's going to go to 830, exactly 832. So I can still see the pile here, and I can still trace around the outline of the pile. See, it's got right in the crook of that. And I'm going to press C to close. And now I'm going to turn off the planar elevation snap. And I'll rotate under the point cloud now, and you'll be able to see what the effects were. So you can see that we traced on the ground points out here, and then when I turn on the planar elevation snap, we used a fixed 832 elevation coming around the edge of this pile. And again, this technique works for retaining walls and or for piles that encroach on hillsides, essentially. So you can see it does a nice job of outlining that, and then we simply select the point cloud and start the volume command. Pick the point cloud and right mouse crossing, select the polyline, and we have our answer. So that was about 9,250 cubic feet of fill, and so you could see the actual point cloud points that were used for the top surface. And what we do is we actually take this bottom polyline and we create a surface from it and do a surface-to-surface volume internally. And so one way that I can demonstrate that is I'm going to right-click on the polyline itself, and I'm simply going to say create surface. And we have some settings here for islands or outer convex triangles, but that's not really the case here. And I'm just going to hit OK. And so now you can see the surface that was created underneath of here, and I can make it a little bit more clear. We can say that's actually a concrete pad underneath this dirt pile. I'm going to turn off the point cloud as well, just so that we can see this. And I'm going to show you the surface-to-surface volume command. So I'm going to pick the volume command again, and this time I'm going to pick the top surface. And now I'm going to select the bottom surface. And we get a cut volume and so your cut and fill is going to be a little different. So if you pick the bottom surface first versus the top surface, then they'll just be reversed. But it's still your volume. And you see that we get almost exactly the same number as we got from the previous command, which is 9,250 or so cubic feet. But that is the actual technique that we use internally. And then you can see that it also works from surface to surface as well. So that's surface cleanup, for volumes, creating volume reports, and then doing these tricky little volumes when you have a pile that encroaches on another pile or onto a concrete wall. And the retaining walls are even easier because you just take the elevations of the retaining walls at the corners, set your planar elevation to that, and so once you draw along the ground points, you just turn on the planar elevation stamp, and you from the top down, you just trace right along the inside edge of that wall, and you'll get a very accurate result for your volumes. So that is volumes and some advanced techniques using Carlson Precision 3D 2018.